So let us discuss some of the numericals. The first one is like this: 3 point charges q, minus 4q, 2q are placed at the vertices of an equilateral triangle of side L. Obtain the expression for magnitude of the resultant force acting on the charge q and find the amount of work done to separate the charges at infinite distance. So this is the arrangement. This is an equilateral triangle A, B, C. These are the vertices, and Q, minus 4Q and 2Q are the charges present. And they are asking us to find out the resultant force acting on the charge Q. This we already done, or this method we already studied. This is chapter 1 question. Therefore you please do this as a homework, and the result is written F is equal to 1 by 4 pi epsilon 0 q square root 12 divided by L square. Please try yourself and find out the answer. And the second part of the question I am going to explain. Find out the amount of work done to separate the charges at infinite distance. So actually, what is the potential energy? The potential energy is the amount of work done to assemble the charges at these distances from infinity. So potential energy is the amount of work done to assemble a system of charges. Now, what is the work needed to separate the charges into infinite distances? That will be equal to negative of potential energy. Potential energy is the work needed to assemble the charges from infinite separation, and the work needed to separate the charges to infinity will be the negative of potential energy. So we have to find out the negative of total potential energy. Here three pairs are there: negative of potential energy of AB plus potential energy of AC plus potential energy of BC, and potential energy of AB is 1 by 4 pi epsilon 0 q into minus q divided by L, because q charge is kept here, minus q charge is kept here, distance between them is L, that is given in the question, plus potential energy of AC 1 by 4 pi epsilon 0 q into 2q divided by L plus 1 by 4 pi epsilon 0 2q into minus 4q divided by L, that is a potential energy of CB. Minus 1 by 4 pi epsilon 0 is taken out, minus is already there, 1 by 4 pi epsilon 0 is taken out, minus 4q square divided by L plus 2q square divided by L minus 2 into 2, 4 into 2, 8q square divided by L. And in the next step you can take q square by L also outside, and what remains inside the bracket will be minus 4 plus 2 minus 8, so that will be minus 10. Therefore, the result will be minus of the minus plus 1 by 4 pi epsilon 0 10 q square divided by L. So this much work should be given by the external agent, then only this arrangement of three charges can be separated to infinite distance. Now the next question is, so you can read 4 charges plus q minus q plus q and q are, and minus q, this is the fourth one is minus q, are placed are to be arranged respectively at the four corners of a square of side A. Find the work required for this purpose. The second part of the question is, a charge q0 is brought to the center of the square. Now how much extra work is needed to be done? So this is the question. So I am going to draw the representation, a square A, B, C, D, where q minus q, again q minus q charges are there. Length of the side of the square is A, and this is the center of the square where I want to put an extra charge q0. Let us address the first question. What is the work done to assemble the charges at this particular distance? We already studied that work done to assemble the charges is nothing but potential energy, and you can see how many pairs are there. This is a pair of q and minus q, this is a pair of q and minus q, this is a pair of q and minus q, this is a pair of q and minus q. So 4 pairs are there. The charges are q and minus q separated by a distance A. Therefore 4 times potential energy of AB. AB is also Q and minus Q separated by a distance A. There are 4 pairs like that. Therefore, 4 times potential energy of AB plus potential energy of AC. This another pair plus potential energy of BD. This another pair. So altogether 6 pairs are there and 4 pairs are equal. And what is that? 4 times 1 by 4 pi epsilon 0 Q into minus Q divided by A plus 1 by 4 pi epsilon 0 Q into Q divided by AC plus 1 by 4 pi epsilon 0 minus Q into minus Q divided by A BD. Now the question arises, what is AC and what is BD? Now AC can be obtained using Pythagoras theorem. AC is equal to root of AD square plus DC square. That will be root of A square plus A square. That will be root of 2A square. A square can be taken out, A root 2. AC due to symmetry, that will be equal to BD. That will be A root 2. Now I am going to substitute all these things here. W work needed is equal to 4 into 1 by 4 pi epsilon 0 Q into Q minus of Q into Q minus Q square divided by A plus 1 by 4 pi epsilon 0 Q into Q square divided by AC, that is A root 2 plus 1 by 4 pi epsilon 0 minus Q into minus Q, that also Q square divided by A root 2, because BD is also A root 2. Now certain terms can be taken out. I am taking Q square divided by 4 pi epsilon 0 out. When I take Q square divided by 4 pi epsilon 0 into A out, what remains inside the bracket is a minus 4 plus 1 by root 2 plus 1 by root 2. So 1 by root 2, 1 by root 2 plus that will be 2 by root 2, that will be root 2. Therefore the result will be Q square divided by 4 pi epsilon 0 A into minus 4 plus root 2. This much work is needed to assemble the system of charges from infinite separation. Now I am going to place another charge Q0 at this distance, at this position, at the center. Now what is OA and what is OB and what is OD and what is OC? That will be equal to half of AC. We already studied AC is equal to A root 2. Therefore these distances will be A root 2 divided by 2. That will be A by root 2. Now, work needed to place a charge where the potential is V0 or VO will be work needed is equal to VO times Q0. Now, what is VO? The potential of the sender. Now, that will be equal to sum of 4 potentials. Potential at the sender due to charge at A plus potential at the sender due to charge at B plus potential at the sender due to charge at C plus potential at the sender due to charge at D into Q0. Now what is the potential at the sender due to charge at A? 1 by 4 pi epsilon 0 charge divided by distance. Distance we already said A by root 2. A by root 2 plus potential at the center due to charge at B. Charge at B is minus. Therefore minus of 1 by 4 pi epsilon 0 Q divided by A by root 2 plus 1 by 4 pi epsilon 0 Q divided by A by root 2, that is VOC. Similarly VOD also will be minus 1 by 4 pi epsilon 0 Q divided by A by root 2. And you can see there are two terms which are positive, there are two terms which are negative. They cancels out. The resultant potential at the center will be 0. Therefore the work needed would be 0 into Q0, that will be a 0. So no work is needed to take a charge Q0 from infinity to that particular point, diagonal or the center of that square. So the result will be 0. Now one more question I want to discuss. Very carefully you have to listen this particular question. Two concentric spheres of radii capital R and small r are connected with a conducting wire. Let a charge capital Q is given on the surface of the bigger sphere and a charge small q is given on the surface of the smaller sphere. Determine the direction of charge flow if capital Q greater than small q. So please analyze this particular situation. There are two spheres. One is bigger of radius capital R. Second one is smaller of radius small r. This is the radius r. And small q charge is given on the surface of the inner conductor, capital Q charge is given on the surface of the outer conductor, capital Q is bigger than small q. Now these two conductors are connected by a conducting wire. Now they are asking what is the direction of the charge flow. So automatically the common sense may tell us that the charge of the bigger conductor is more, therefore charge will flow from bigger conductor to smaller conductor. Now let us analyze this. The electrostatics of charge flow we already studied. The charge will always flow from higher potential region to lower potential region. All the charges are supposed to be positive. Now question is, what is the potential of the bigger sphere? Potential of the bigger sphere VB is equal to potential due to its own charge plus potential due to charge on the smaller sphere. Now what is the potential due to its own charge? 1 by 4 pi epsilon 0 capital Q divided by capital R, that will be the potential due to its own charge. Now the smaller sphere also produces a potential at a distance capital R from its center. So that potential will be 1 by 4 pi epsilon 0 small q, that is a charge on the smaller sphere and a distance capital R. So there are two potentials on the surface of the bigger sphere, potential due to its own charge plus potential due to charge on the smaller sphere. Therefore it will be 1 by 4 pi epsilon 0 q divided by capital R plus 1 by 4 pi epsilon 0 q divided by small q divided by capital R. Therefore total potential of the bigger sphere will be 1 by 4 pi epsilon 0 capital Q divided by capital R plus small q divided by capital R. Put as equation number 1. Now let us analyze what is the potential on the surface of smaller sphere. Potential on the surface of smaller sphere is equal to potential due to its own charge plus potential due to charge on the bigger sphere. This is because the smaller sphere inside is inside the bigger sphere. So inside the bigger sphere the potential remains same. We already studied that the interior of the sphere, conducting sphere, electric field is 0 but electric potential remains same, and that will be equal to potential of the surface. So inside the bigger sphere the same potential is residing, that will be equal to potential of the surface. Therefore the smaller sphere is residing inside the potential of the bigger sphere. So there are two potentials. Number one, potential due to its own charge plus potential due to charge on the bigger sphere. Now what is potential due to its own charge? 1 by 4 pi epsilon 0 small q divided by small r, because charge given on the inner sphere is small q, the radius is small r. Now the inner sphere is residing inside a potential, that is a potential due to bigger sphere, that will be 1 by 4 pi epsilon 0 small q capital Q divided by capital R. So there are two potentials. Now I am going to take 1 by 4 pi epsilon 0 out. What remains is capital Q divided by capital R plus small q divided by small r. Look at equation number 1 and 2. So here you can see the denominator is capital R and capital R, but here it will be capital R plus a small r. So you can see the denominator is lesser in equation number 2. Since the denominator is lesser in equation number 2, the numerator will be more. So that means in this particular situation, the potential of the smaller sphere is bigger than potential of the bigger sphere. No matter what is the charge given. The charge given on the smaller sphere is small. The charge given on the bigger sphere is more, but irrespective of the charge given, if the spheres are arranged like this concentric, the potential of the inner sphere will be more than potential of the outer sphere. Therefore, if they are connected by a small conducting wire like this, what happens? The available charge on the inner sphere will automatically shift to the outer sphere and will be spreading on the surface of the outer sphere. So the direction of charge flow is determined by the potential or potential difference. Here potential of smaller sphere is greater than potential of bigger sphere. Therefore Whatever the charge given on the surface of smaller sphere will be automatically shifting to the bigger sphere. So this will be the answer. The charge will flow from smaller sphere to bigger sphere.